Now we're going to put everything all together and graph a function with a slant asymptote. Starting off with domain, a lot of this will be review of what we saw yesterday. Set the denominator not equal to 0 and solve for x. So in this case, our domain is x cannot equal 1. Vertical asymptote. On this one, we need to factor the numerator because that could be a whole instead of an asymptote, because it could be a factor of the numerator. So our numerator multiplies to 1 and adds to -1. Thinking about t-chart, the only values that multiply to 1 would be +1, which would add to 2, or -1 times -1, which would add to -2. So this one does not factor, which means that factor in the denominator does not cancel. So x equals 1 is a vertical asymptote. We know we have a slant asymptote because that's what we're focusing on. The reason we know that is the power in the numerator is 1 bigger than the power in the denominator. So we're going to go ahead and divide. Now this one we can use synthetic division for because in the denominator we have a binomial, just x minus 1. So I'm going to use my synthetic division on this one. Setting up the coefficients from the numerator, 1, -1, and 1, and dividing by the opposite of the -1 that we see in the denominator. Bringing down our 1, multiplying, adding, multiplying, adding. We don't really need to worry about the remainder. So in this case, we have the equation y equals 1x. Again, dropping a power from the numerator. To find the x-intercepts, we set the numerator equal to 0. So we have x squared minus x plus 1 equals 0. We already know this doesn't factor, so we're going to use quadratic formula. X equals the opposite of b plus or minus the square root. B squared minus 4 times a times c all over 2a. Under the radical, we get 1 minus 4, which is a negative number, which means we have no real solution to this. We don't have imaginary solutions, but we can't plot imaginary numbers on a real number line, so there are no x-intercepts. Y-intercepts, we substitute 0 for x and solve, or we evaluate the function at 0. So in the numerator, we have 0 squared minus 0 plus 1. And in the denominator, we have 0 minus 1. So we have a y-intercept of 0, -1. Checking for symmetry, we substitute -x into the function and see what happens. So in the numerator, it becomes -x squared minus -x plus 1. All over in the denominator, -x minus 1. This simplifies to x squared plus x plus 1. All over -x minus 1. This is not the same function we started with, so it does not have y-axis symmetry. If we factored out a negative, there's a couple of different ways that we could factor out a negative. I would factor it out of the denominator because my denominator, both pieces have a negative sign on them. However, the numerator is not the same and neither is the denominator, so that still didn't work either. So we have no symmetry. Graphing what we know before we decide if we need to use a t-chart. We have a vertical asymptote at x equals 1. We have our slant asymptote through y equals x. So that would go corner to corner for the graph. We don't have any x-intercepts, but we had a y-intercept at -1. I could substitute a couple of negative values into the function to see what was going on, but really I'm just going to use those two asymptotes and get a little sketch of a curve between those two asymptotes. Again, the graph will approach those asymptotes. So if you wanted a more precise graph, you could absolutely substitute -1, -2, etc. into the function. But I have no idea what's going on off to the right of my vertical asymptote. So I am going to do a t-chart with a couple of values, probably just 2 and 3, and I think that will give me a good idea of what's going on with my function. So I'm going to substitute 2 in for x. So I get 2 squared minus 2 plus 1 in the numerator, all over 2 minus 1 in the denominator. That gives me 3 over 1, or 3. So I'm going to plot the point 2, 3. And I'm going to substitute 3 in as well, see what happens there. So I get 3 squared minus 3 plus 1 in the numerator, all over 3 minus 1 in the denominator. That gives me 7 over 2, or about 3.5. So again, I can see that I will have a curve between my two asymptotes, hitting those 2 points that we found. So in this case, our graph looks like it's a couple of parabolas that are a little bit slanted.